I'm Wojtek. I work at Dashbit, and let's talk about ReqA, the HTTP client. So I like to say that ReqA is batteries included. So kind of the analogy, you take something out of the box, it already has the batteries included, it's ready to go. And so that was my idea that that ReqA, you would just install ReqA, and you would be able to do common tasks very easily. You wouldn't necessarily need to maybe reach for other tools, for other libraries. You wouldn't necessarily need to write a lot of code of your own for the common tasks. So that's kind of what I had in mind. So let's take a look at how let's show how it looks like to work with ReqA. So here, let's say we have an IEX session, and we can mix install ReqA, and we can call req.get, and this is what we would get back. So here I'm calling the GitHub JSON API for the ReqA repository, and I got the ReqA response struct. So we got the status, so it's 200 OK. We got headers, we got back a lot of headers. I'm just showing you two, and it's these two for a very particular reason. And we also have the response body. So the content encoding header means that the server over the wire has compressed the response body using this algorithm. And when ReqA sees this header, it will automatically decompress the body. And as a matter of fact, the servers don't compress response bodies by default. They would only do that when asked to, when the clients would set the accept encoding header. So ReqA does set that header. So kind of the idea is that ReqA is pretty opinionated. It has particular defaults, which you can opt out of if you want, but it has these defaults that, so in this case, ReqA would set the accept encoding header, the server will compress the response, ReqA will automatically decompress it. So another header that we got is content type. Here it's application JSON, and similarly, ReqA will automatically decode the JSON. So instead of getting the JSON string or the JSON binary back from the server, it got automatically decoded into the Elixir map. So make the call again. This is usually what I would do. I would usually reach out to the body field directly, and then if it's a JSON API that would again be automatically decoded, I would reach into the JSON document, maybe grab a field. So here we have the tagline, and this is what I like to call my ReqA hello world, if you will. It's just 2 lines of code, or 1 line of code if you don't count the installing part. And it does quite a lot of things. You know, set some headers, respond to some headers. So yeah, this is just a short overview. Okay, so instead of making the call right away, what we can do as well is this. So first build up the request, and only later on execute it. So again, we can reach into the field, and we get the same result. So what are the batteries included? What are the features that we have in ReqA? So, and I would very much call it a feature. One of my goals is to have this easy to use high-level API in the ReqA module. So we just we have a handful of functions, and it's really I hope it's really easy to use them to again get common tasks done fast. Another feature is request body compression and automatic decompression. So we've seen the decompression already. And here I write that these features are done via these steps. And we're going to talk about steps a lot pretty soon. By default, ReqA ships with the gzip and deflate compression algorithms support. just because OTP does. But if you install some hex packages, ReqA will pick them up and will support broadly and the STD compression algorithms as well. ReqA also has body encoding and automatic decoding. So again, it can automatically decode JSON or some other formats. It supports, so it's very easy to encode parameters as query strings. There's support for authentication, including the .NET RC file, which is commonly used in scripts. It's very easy to make range requests, follow redirects, retry on errors, raise on errors. We're going to talk about that a little bit later. We have some basic support for HTTP caching. Can easily set the base URL, and we can run against plugs. So there is support with the plug library, and we have pluggable adapters. So by default, ReqA uses the Finch HTTP client. Finch in turn uses the Mint client, so it's kind of like these layers. We're going to talk about Finch and adapters a bit later on. As I mentioned, all of these features are implemented as steps, and steps are just functions. So here is a documentation for one of these functions, for one of these steps. So this is the follow redirects step. So my goal, one of my goals was to have good documentation, to have comprehensive documentation for the library, and I knew that I would have, I wanted to have a lot of features, and so maybe it would be kind of hard to document them all in the same place. But at the same time, I wanted to have this extensible design, which we're going to talk about soon. But kind of nice maybe accident, maybe nice consequence of this steps or functions-based design is that I can now document every step, every feature of ReqA separately. So here we have the documentation for the step. It accepts a bunch of options. So, for example, by default, ReqA follows redirects, but you can turn it off. You can set max redirects. We have some code samples as well, and in the sidebar, you can see some other steps as well. So we have three kinds. Let's talk about steps. So yeah, so to stretch the batteries analogy that I mentioned earlier, let's talk about replaceable batteries. So if the steps, the features are the batteries, let's talk about how we can replace them, how we can maybe rearrange them in different ways or write new ones, write new features. ReqA has these three main parts. So we have the ReqA, the high-level API. We have the ReqA request module. So this is the lower-level API. This is an API that you would use to write your own steps. This is the API that was used to write all of the built-in steps. And this module also contains the request struct. And finally, we have the ReqA steps module, which is just the collection of the built-in steps. So let's talk about this structure. When we call req.new, here just for the presentation, I'm passing two options, the URL and disabling the follow redirects. What we will get back is structure. It has a bunch of fields. We are going to talk about them in groups. So we have the basic HTTP stuff, so method, URL, headers, and body. We have options, so we keep track of the options that were passed to ReqA. And we even keep track of all of the available options. So we are going to talk about that a little bit later on. We have the halted, which we might talk, and we have the adapter. Again, we use Finch, and now we have the steps. So on the request structure, we keep track of the steps. And so here are the request steps. They are happening. So these steps are used to build up the request. So to maybe set some headers, maybe some default headers, maybe some other headers based on options. They are set to set or change the request body, the URL. And after we actually make the network call, we have the response steps. So we have things like retrying in face of errors or following redirects or decompressing the body. And we have error steps. So that is when we got an error. And we have the private field just to keep some data around between steps. And if we, so we've seen this this call. So it roughly equates to the following. First, we would build up the structure, and then we would pass it on to the steps. So a step is just a function. It accepts a request and returns a request. So we can kind of like pipe the request through these steps. So maybe we set the user agent header, we encode the body and compress the body, and so on and so forth, going through these steps. And then we would hit this run finch step. So again, ReqA uses the finch library by default. And this step is a little bit different. Instead of returning the request, it would return one of these two things. Either the request response tuple, that is when we got a HTTP response, or if we got an error, so maybe there was a network error, the server is down, or there was a timeout, we would get the request exception tuple from this step. So in the first case, we would take the request response tuple and again pass it through, this time, response steps. So if that error was, if there was a HTTP error, maybe something like 500, maybe we want to retry. Or if it was a redirect, maybe we want to follow the redirect. And if there was a body, we want to decompress it and decode it, and so on. And for the request exception case, we would similarly take it and then pass it through error steps. So this is roughly how ReqA works. It is all about passing data around through steps or through functions. This is not quite that simple, though. Think about it the way that after calling each step, there's like a breakpoint, a place where ReqA takes over and changes the flow of control. But roughly, it's all about passing data through steps. So let's talk about steps in some more details. Again, we have the three kinds. Let's take a look at writing our own step. So here I'm just making a very basic request, and let's add a step that is going to just print some debugging information about the request. So again, step, just a function. It takes a request and returns the request, and we can maybe IO inspect the URL. And this is how we would use this custom step. We would call the ReqA request append request steps function, passing this or some other steps. The append word is kind of important here. The order of the steps matters a lot. It only makes sense to first decompress the body and then decode it, not the other way around. So that's why we have append and prepend functions. And that's about it. So let's talk about the contract, the shape of the steps. So again, request steps, just taking and returning request. Similar for responses, taking the tuple and returning the tuple, and same for errors. A contract like this can get you pretty far. We can implement a lot of the functionality, but it is not quite enough to implement all of the features that I wanted. So for this reason, a request step can also return the request response tuple. So here's an example. Maybe we have a read from cache step. So we take the request, we check if we have a cached response for this request. If we got a cache hit, it doesn't make sense to actually make the request anymore. We already got the response, so we can return the request response tuple. And what's going to happen? And so this is that hidden control flow by ReqA that I mentioned. When ReqA gets this request response tuple in this scenario, it will stop passing the request through the request steps. It is going to take the tuple and pass it through response steps. Similarly, a request can return the request exception tuple. So again, here's an example. Maybe we have circuit breaker step. So if the breaker is open, if the breaker is open, we don't even want to attempt making a request. So we can return the request exception tuple. And again, ReqA is not going to make the request. It will stop passing it through these steps. It's going to take this tuple and pass it through error steps. And we want to do that because maybe we have error steps around retrying, automatic retries, or maybe logging errors and things like that. So similarly, the response steps contract, it can return an exception. So it goes through the error steps, and error steps can return responses as well. Okay, let's see let's see ReqA in action. So I'm going to open up a live book that I prepared. It's just some very basic boilerplate, which we've seen before. So just the hello world, if you will, and we got the response. Okay, so let's change the HTTPS to HTTP. When that happens, when you make HTTP requests to the GitHub API, it will return a redirect. It's like, hey, you should be on HTTPS. So here the follow redirect step is there is a debugging statement that it says, oh, we are automatically redirecting. So we got the same result. However, if we disable the option, then we would get the response that we expected here. So status 301, the location header. Okay, let's fix up the HTTPS. Okay, now let's do this. Let's build up the request struct using this URL. And let's run it. We should get the same result. But now what we can do is take, let's say you want to make a bunch of requests. So let's take the unique part and change this to base URL. So here we are setting the base URL, and here we can now set like a URL fragment. So again, here we have the same result, sorry, but what we can now do is take, okay, we can take this, sorry for that. And maybe let's check out Finch. I mentioned Finch a couple of times. Let's see the description. So Finch is Elixir HTTP client focused on performance. I really cannot praise Finch enough. It is really excellent. It truly is focused on performance, and the performance is excellent. And I like to say that Finch is focused on performance, so that ReqA doesn't have to be. Okay, so let's do something else. Let's actually hit a bad URL. Let's hit this 404 URL, and what we got back is nil. But the reason is, if we check the body was automatically decoded, but it didn't contain this description field, so we got a nil. And if we write the code like this, it kind of assumes that we got the successful response and we are trying to get the value out of it. So to make it a little bit more assertive, what we can do is set HTTP errors option to raise. And now ReqA will automatically raise that, you expected a successful response, but you got a 404 error, and this is the response body. So this is particularly useful in maybe the scripts where you don't want to do explicit error handling, but if something goes wrong, something unexpected went wrong, you still want to get a good error message. So we have a lot of these different options, and sometimes maybe you can forget how an option was exactly called. So if you mistype the option name, ReqA will raise an error. So here it says that, oh, unknown option HTTP error. Did you mean HTTP errors? So this is an affordance to help you out when you made typos, to kind of get back into the flow quickly. And we are able to do this exactly because, as I mentioned before, we keep track of all of the registered options. And if you write custom steps, maybe your custom steps accept some specific options, you can register these options with ReqA so that we can get this nice error message. Okay, so let's talk about something else. So one of my goals with ReqA was to have a to make it easy to use ReqA with tests. So let's say you you integrate with some third-party API, and you are using ReqA for it. Let's see how it looks like. So maybe you are familiar with a library called bypass, which is this really nice idea. What bypass does is it spawns a kind of ad hoc HTTP server that you can control using the plug API. So taking the con and returning the con. So it would look like this. So plug con and then maybe send response. Let's do con and then some body. And ReqA actually supports this style as well. So let's assign this to a variable. And now we can pass the plug option. Let's change this a little bit. And let's see what happens. So what happened was, instead of hitting the network, instead of making the call, we hit the plug. So this is pretty useful to, this is pretty useful in tests. So a very similar feature, I mentioned that ReqA, again, uses Finch, but it has pluggable adapters. You can easily change them. You can write your own. So let's do exactly that. Instead of passing the plug option, we're going to pass the adapter option. And adapter, instead of taking a con, it takes a request and it returns the request response tuple. So a response, let's just do new, it's going to be body hello. Oh, okay. Yeah, so we got the body hello. So yeah, this is another way to maybe do this to create mock responses, especially in tests. And if you happen to be working with JSON APIs, there is a lot of convenience there as well. So instead of the new, you can use the JSON function and return maybe some JSON document. It's going to be, we'll automatically set the content type headers from the adapter. And here the body is automatically, so the body is already an Elixir term. And this is because ReqA automatically decodes it. So if we pass the raw option to true, a raw option basically gets you the raw request, the raw response. We would see that over the wire, it looks correct. Let's actually use this adapter to look a little bit more into what ReqA does. Let's inspect some of the attributes of requests. So let's check out the URL. We are actually going to wrap this in the. We are going to pretty print the URL, and let's check out the headers. And let's check out the request body. Okay, so we got this. We got the URL. Again, the URL is about GitHub, but we are not hitting GitHub. We are hitting our fake adapter. The headers are the following. So ReqA by default sets the user agent header to ReqA. And then we have this accept encoding header. So we request the server to compress the body. And what we can do is, so I mentioned that if we install some hex packages, we can kind of change this behavior. So if you are not familiar, this is one of the recent features. These are the keyboard shortcuts for Livebook. And one of the newer ones is show package search. So it's SP. So let's do SP. And we can easily search for packages. So let's add the broadly package. It nicely adds it to our mix install. So let's install it. Let's make the request again. And now the accept encoding contains broadly. Okay, so let's remove broadly. And let's do something else. So I mentioned, okay, let's switch this URL just a little bit. And let's add some query strings. So we have the params option, and it nicely adds the query string. Instead of making a GET request, let's make a POST request so we can set the body. It's going to be high. So indeed, we got the body as the following, but what we can also do is use the form option. So this is the encode body step. And what it's going to do is it will your form URL encode this data. So it sets the appropriate content type header. It URL encodes the body. And instead of the form, we can also do JSON. So this is a very easy way to JSON encode the body. The content type is application JSON. And here, if you are not familiar with it, this is something called IO list. It's just a very efficient representation of. It's a way that Erlang, the virtual machine, can efficiently concatenate strings without using more memory. So just for the presentation, let's check it out. So we have this IO list, but if we IO puts it, we have the expected result at the encoded JSON. Okay, so these are some of the built-in steps. And now let's do something else. So one of my goals with ReqA was the extensibility, which we can do with steps, with the custom steps. And now, so as you write these custom steps, to make it even easier to use by others, you can package them up into plugins. So let's check out one of these. Actually, let's first let's change some stuff around. And let's hit GitHub. Let's hit the GitHub API. So the user endpoint is getting information about the authenticated user. So let's add a let's add another plugin. Let's add another package. So sp rec GitHub. Sorry about that. And let's install the package. And let's add it to our pipeline. So rec GitHub attach. And now what happened is we get this information, paste this user code at this URL. So this plugin does the GitHub device flow authentication. So let's take the code, paste it here. So this is this project by me. Let's authorize it. Go back to our livebook. Oh, of course I forgot the method. So the method should be get. Let's do it again, and we are good to go. Let's make sure we got the right user. We got me. So okay. So the idea is that there are steps that are make it happen. But basically, they are packaged up as this plugin. You can very easily install it, and it handles GitHub authentication. So for you, again, this is that out-of-the-box experience. It's very here. My goal was to make it very easy for people to use the GitHub API. You can authenticate very easily. Let's check out another plugin. So let's hit the Elixir homepage. We are going to get back the HTML, and let's add another package. So it's going to be rec easy HTML. Let's install it. And now when we make the same request, we are going to get, we need to attach it, of course. Now we are getting a different result. We are getting this easy HTML struct, which under the hood is the decoded HTML, but because it's a struct, we can implement protocols. So it implements the inspect protocol, so we can pretty print the HTML so that it's easy to follow. And we also implement the access protocol. Using this notation, we can do the CSS queries. So like find all of the divs. I know there's an H5 element on the website. When we do this, we will find the Elixir tagline. Let's do another. Let's check out one more plugin. One of the recent focuses was in the Elixir community was around machine learning. So for this, you need some training data sets. There is this this OSS data sets project. It's stored on S3. So let's grab it from S3 really easily. We can add the ReqA S3 package, mix install it, attach it to our request, and now the URL can be just S3. And what it does under the hood, it automatically does the API method to grab to list the bucket contents. But for us, it's just doing this nice little URL, and we get this very useful information. We can grab the names of the objects, and when we request them, we would get the object contents. So these are some of the steps. Let's check out some other ones. So my colleague Ale created integration for the Google BigQuery and AWS Athena. I created another one for the Hex API. There are some other plugins in the works, but yeah, this was just a short demo of ReqA. Let's go back to the presentation. So to again stretch maybe the batteries analogy just a little bit more, what is missing in ReqA? What are the missing batteries? I want to add cookies support. I want to add request streaming support, which is actually not that hard because Finch already does it very well. But I'm not adding it until I have a good idea how to do response streaming, which is a little bit tricky with the steps contract. So I haven't figured it out yet, but that's something that I want to do before I can release ReqA 1.0. And one more thing, as I was preparing for this presentation, I was planning to do a comparison of ReqA against some other popular HTTP clients, but I realized that with the limited time, I couldn't really do them justice in a short talk. So I decided not to include this in the presentation, but I am very happy to talk about any or all of the HTTP clients and kind of how they compare with ReqA. And yeah, that is about it. These are some of the links. So the ReqA GitHub project, the ReqA documentation, and thank you very much for your time.